Hello everyone, my name is Harsha Chaudhary. Welcome back to my channel. In this series, we cover NumPy from beginner to advanced level. In my previous series on NumPy, we only cover basic or beginner level. So if you only want to study beginner level, so for that you watch my previous NumPy series. I share the link in the description. So come to this series. In this series, we cover NumPy from its basic to the advanced level. Like what is NumPy, NumPy Array versus Panda list, installing NumPy, and creating ndarray, and much more. So let's start with what is NumPy. NumPy is an open source Python library. It is a linear algebra Python library. It stands for numerical Python. It is the core library for scientific and for numerical computing in Python. Using NumPy, mathematical and logical operation on array can be performed. It provides high-performance multi-dimensional array objects and tools for working with array. In Python, dimensions are called as axes, and NumPy array is also called as ndarray. It is faster than Python list because it has binding to C library, pre-compiled C language code. That's why it is faster than Python list. At the core of NumPy package is ND objects, and how we use it ND object with multiple tools which provide by NumPy. NumPy provide fast operation on array like mathematical, logical, shape manipulation, sorting, selection, basic linear algebra, and statistical operation. Now comes to the difference between NumPy array and Python list. NumPy array has a fixed size at creation. After that, we grow it dynamically by creating new array and deleting the original. The element in NumPy array are of same data type. Thus, it will be the same size in memory for all elements of array. One question which pop up on your mind, why we use NumPy if we already have Python list? The answer is because it is faster and more compact than Python list. The array consumes less memory and it's convenient to use. NumPy array essentially come in two favors. First, vector, second, matrix. Vector stand for 1D array like column vector, row vector, and matrix is 2D array. Now come to Anaconda distribution. I recommend Anaconda distribution for this video. So if you don't have Anaconda installed in your system, go and watch my previous video. I share the link in the description and also in the I button. Let's come to the installation of NumPy. If you have Anaconda in your system, go to command prompt and type conda install NumPy. And if you don't have Anaconda, then use this command pip install NumPy. If you are new in my channel, please like, share, subscribe, and make sure to hit the bell icon so you get the notification when I create new interesting video. So let's start coding. I already create Jupyter notebook and write code on it so that it takes less time. I simply explain all the code one by one. So let's get started with installation. As if you don't install till now, you can also write command here to install NumPy, like pip install NumPy, then shift press enter. I already installed NumPy, so there is a message that requirement already satisfied, and there is a warning like pip version, this is on my system and the latest version is this. You simply ignore this warning as it not come in your system. Now, second step is to import NumPy library. For importing NumPy library, you have to give this code, import NumPy as NP. Let's hit enter, shift enter. The most important aspect of NumPy is its array, vector, matrix, and number generation. So let's start with array. Creating array from Python list. First, we define a list which have element 1, 2, 3. Shift press enter to run the cell. Here you can see the my list. Now use this my list in the array function of NumPy to create array. Let shift press enter. Here the array is created, which contains same element as list. Now make some nested lists to create 2D array like this one, my matrix. Shift press enter. Here is the list which we created. There is nested list inside the list. Now it converted it into the 2D array like this. np.array in parenthesis pass this my matrix and shift press enter. Then print this array. Here is the output. 2D array, 3 rows, 3 columns. The most important attribute of ndarray objects are like shape, dim, dimension, types, dtypes, and many more. Let's explore these attributes. First is shape, ARR, the array, this one. Use shape attribute to get the shape of this array. Shift press enter. 3, 3, as it have 3 rows and 3 columns. Now ndim, which give the dimensions of the array, which is 2, as it have row and columns. So it have 2 dimensions. Next is size of array, arr.size. It have 9, as it have 9 elements. That's why its size is 9. Now dtype, the elements type, arr.dtype, int 32, as the element of this array have type is int 32. Now item size, arr.item size, shift press enter, 4. Attribute item size return the byte required by each array element. Now for the data attribute, we use array.data, arr.data to get the data related to the memory of an array. Let's run this cell. Now comes to the type. Type is not an attribute, it is a function as it uses parentheses. We pass the in the parentheses the array, then shift press enter. There is this ARR is NumPy array. Now to set the dimension like this, ND and dim. To set the dimension at the creation of array, we use ndim set to 2 as it have only one list. Then shift press enter here. It has 2 dimensions as it have used 2 square bracket. That's why if you want to get the D and dim, you get 2. As we said, the and dim is 2 here. Now comes to creating ndarray from tuple. As we define X a tuple which contain 1, 2, 3 and pass this X in np.array function and then print it. Let's run this cell. Here is the array. If we use not using print function, simply want to get the data of A, it have array with value 1, 2, 3. Let's come to the data type. NumPy support a large variety of data types like bool, int, float, complex, and many more. Like I mentioned these in this line. We also set dtype during the creation of the array. As we did the same in set dimension during the creation of the array, we also did same for dtype. As we put dtype equals to complex and shift press enter to run this cell, and here is the output. And if you want to use np.int32 inside mp.dtype and store the value inside a variable dt and print it, let's see what we get. And here is the output. If we want to put this 32 in place of complex, let's see what is the output. Sorry, it have np.32. If you want to get the dtype, use this code and we get the 32. And if we want to set this in 16, we get 16. I hope you understand data types, how to generate array to a particular data type. Let's come to built-in methods. There are lots of ways to generate array in NumPy. First, we use arrange function to generate an array. Let's see. np.arrange 0 to 10. Let's see the output. It have value from 0 to 9. With the one difference between these adjacent values. As the by default, the step size is 1. Now set the step size 2 and see what is the output. Here you can see the step size is 2 and the difference between the adjacent is also 2. We also pass float in the argument like this. Now comes to 0 and 1 function. We use 0 function to generate array of zeros like this. np.0 pass 3 as a parameter. It generates an array with 3 elements. Now we set array numpy.zeros 5 into 5, like 5 by 5 matrix will be the result. It have 0 element and have size is 5 by 5. Now come to the ones function np.1 and set the parameter 3. It generate array of 3 element. All values are 1. Now generate a matrix of 3, 3. Here is the output. Let's come to the next function, linspace. It is very useful in plotting a graph as it is very similar to arrange function also. Let's see what is the difference. We set 0 and 10 and step size 3 as it produce 3 values between 0 to 10. Now we set 50 values between 0 to 10. We get 50 values. We also get the interval of the adjacent values by setting ret step is equals to true. Let's see the output. Here is 0.25 is the difference between the 2 adjacent values. Now comes to the another function, which is I. It is used for creating a identity matrix. I hope you study this identity matrix in linear algebra. Let's print this array. Here is 5 by 5 matrix is generated. In diagonal, it have 1 value and the rest of the elements have 0 value. We also give 3 here and see what's the main like this. Like 7. You can play with these numbers. Let's come to the another function, which is empty. Empty method is used for creating an empty array. Let's see in this line, we create a empty function. We create an empty array of 2, 3 size. Let's print it. Here is the output. 2 rows, 3 columns. As we want to set 3 by 3, it gives 3 rows or 3 columns. We want also set the datatype is int and order is ascending. Let's run it. Here is the value. 2 columns, 3 rows. Let's come to the next part. In this part, we generate random values inside the array. Let's see how we can do that. First function which we using for random generation is random.rand. It give the randomly generated values between 0 to 1. Let's run this. Like there are two values as we give the parameter 2. If we give two parameters 5, 5, let's see what is the output. 5 by 5 matrix is generated. Now comes to the another function rand n. We simply use this np.random.rand and pass 2 as a parameter. Shift press enter to run the cell. Here we can get two values. It is not same as this random generation because it have the value between 0 to 1. By this function, we also get minus values. Let's set parameter 5, 5 and see what happened. Here we can get the matrix of 5 by 5. The another function is random int. It returns integer values from low to high. We set low to 1 and high to 100. Let's see what the output is. Here is 57. As we not give third parameter like 1, by default it is 1. If we want to give 2, it generates two values between 1 to 100. Don't worry if you not get the same value because it is randomly generated values. Now for this cell, run it. Here we can get 10 values between 1 to 100. That's it for NumPy Part 1 lecture. If you like this video and it helps you, so don't forget to like, share, subscribe, and make sure you hit the bell icon. Thank you for watching. See you in Part 2, NumPy Part 2 lecture.